May 6, 1942, Aberdeen, Proving Ground, Maryland, where the morning fog still clung to the edges of the artillery range, like gun smoke that refused to dissipate. Colonel Leslie Skinner stood beside a wire coat hanger that had been twisted into something resembling sights, mounted atop a 5-foot steel tube salvaged from a scrap heap. The tube looked absurd, like a stovepipe someone had forgotten to install, and the contraption attached to it seemed even more implausible, a crude framework of metal and wood with 2 dry cell batteries tucked into what could generously be called a shoulder stock. Beside him, a young engineer named Edward Oule shifted his weight nervously as a line of military vehicles approached through the haze, their headlights cutting parallel lines through the dawn. Neither man knew that within hours this ridiculous-looking device would be ordered into mass production, or that it would reshape the nature of armored warfare itself, or that General Dwight Eisenhower would later call it one of the most crucial tools of victory in the entire Second World War. All they knew was that 5 different Spigot mortars had just failed to hit a moving tank target, and now it was their turn to either validate 18 months of rejected proposals and sleepless nights, or join the pile of abandoned ideas that littered every proving ground in America. Skinner loaded a rocket from the rear, connected the trailing wire, and handed the tube to Brigadier General Gladian Marcus Barnes, the head of Ordnance Research and Development, who had stopped his inspection tour specifically because he noticed all the flames and whooshes coming from this corner of the range. Barnes shouldered the weapon, squinted down the coat hanger sights, squeezed the electrical trigger, and watched as the rocket screamed downrange in a trail of fire and smoke, punching directly into the moving tank with a sound like thunder compressed into a single metallic syllable. He fired again, a direct hit, and then the other brass wanted turns, and within 20 minutes every available round had been expended, and General Electric was being ordered to produce 5,000 launches in 30 days, an order they would complete with exactly 89 minutes to spare. What nobody mentioned in that moment of triumph was that just 6 months earlier, this entire project had been considered a dead end, that Skinner's original sketches from December 1940 had been dismissed because no suitable warhead existed, or that the weapon now being rushed into production had a name borrowed from a musical instrument made of stovepipes and whiskey funnels played by a comedian on the radio. The story begins not with fire and metal, but with futility, with the crushing recognition that came to every infantryman who watched a German panzer advance across open ground, that recognition being the sudden, visceral understanding that a rifle bullet would bounce off armor plate like rain off a steel roof. Anti-tank rifles required superhuman strength to carry and fired rounds that could barely penetrate the lightest armor. Anti-tank guns were effective, but required crews of 6 or 8 men, weighed hundreds of pounds, and could not be easily moved once positioned. Grenades required suicidal proximity, close enough to smell the diesel exhaust and hear the treads grinding dirt and stone. The fundamental problem facing Allied infantry in the early years of World War II was not courage, or training, or even numbers, but physics, the simple equation of kinetic energy and armor thickness, and the brutal reality that a man on foot had no practical way to harm a machine that weighed 30 tons and could kill him from half a mile away. Leslie Skinner understood this problem with the clarity that comes from direct experience, having served in the Marine Corps during the First World War and spent the intervening decades thinking about how modern warfare had evolved into something that favored steel over flesh in ways that previous centuries could not have imagined. By 1942, he was working at the Frankfurt Arsenal in Philadelphia, running a special projects unit that investigated unconventional weapons, and he had become convinced that the solution lay not in making bigger guns or heavier projectiles, but in fundamentally changing the nature of the explosive itself. The key was shaped charges, a principle discovered decades earlier, but not fully understood until German engineers demonstrated that explosives could be formed in specific geometries that would focus their energy into penetrating jets capable of burning through armor like a cutting torch through butter. The physics were elegant and counterintuitive, using the explosive to collapse a metal liner into a high-velocity stream of molten metal that could pierce steel far thicker than the charge itself. By early 1942, American ordnance had developed the M10-shaped charge grenade, a hand-thrown weapon that could theoretically penetrate several inches of armour. But the effective throwing range was perhaps 30 yards, well within the kill radius of any tank's machine guns, making it more of a desperation weapon than a practical solution. Skinner's insight was that if you could deliver that shaped charge from a distance, you could transform the tactical equation entirely, giving infantry the reach they needed to engage armour before the armour could engage them. The problem was propulsion, how to get a grenade-size shaped charge to travel 300 yards with enough accuracy to hit a moving vehicle. Artillery seemed like overkill, mortars lacked precision, and rifle-launched grenades had neither the range nor the explosive power needed. What Skinner needed was a rocket, and in early 1942, American rocket technology was primitive at best, more associated with fireworks displays than military applications. This is where Edward Ohl enters the story, a young engineer fresh out of Lehigh University who had recently been assigned to Skinner's unit with instructions to solve the unsolvable, to create a man-portable rocket launcher that could give infantrymen the power to kill tanks. Ohl was 24 years old, which meant he brought enthusiasm and a willingness to try ideas that more experienced engineers might dismiss as impractical. The rocket itself was being developed separately, a 60mm projectile that used solid propellant to generate thrust and carried the M10-shaped charge as its warhead. What Ohl needed to figure out was how to safely launch this rocket from a soldier's shoulder without incinerating the soldier in the process, because early rockets generated enormous amounts of backblast, flames and gas that would cook anyone standing behind them. The breakthrough came during a walk past a scrap pile in the spring of 1942, when Ohl noticed a steel tube approximately 5 feet long and 60mm in diameter, exactly matching the size of the rocket. The idea arrived fully formed: put the tube on a soldier's shoulder with the rocket inside, and let the backblast exhaust behind the shooter. It was so simple it seemed stupid, but Ohl immediately understood that an open-ended tube would allow the rocket exhaust to escape safely while still providing enough guidance to aim the projectile. He fabricated a basic prototype and took it to the Potomac River for testing, pointing it over the water and firing to see if the concept had any merit at all. The rocket launched with nothing more than a whoosh, no recoil, no flames licking back at the operator, just a smooth departure and a trail of smoke heading downrange. Ohl realized he did not even need protective equipment, that the exhaust dissipated so quickly and completely that the launcher could be operated in shirt sleeves. What followed was a period of frantic refinement, adding the wire connection system that would electrically ignite the rocket motor, installing the dry cell batteries in a wooden shoulder stock, and fabricating rudimentary sights from whatever materials were available, which, in the case of the Aberdeen demonstration, meant a wire coat hanger bent into a crude ring and post. The weapon had no official name, just the designation T1 experimental launcher, but during those May tests at Aberdeen, someone watching Skinner and Ohl fire the ridiculous-looking tube commented that it looked like Bob Burns's Bazooka, referring to the comedian's famous musical instrument made from stovepipes and whiskey funnels that made sounds like a wounded moose and had been a fixture on radio shows throughout the 1930s. The name stuck with the immediate and inexplicable permanence that only the best nicknames achieve, probably because it captured something essential about the weapon's crude, almost comical appearance, this long metal tube that looked more like plumbing equipment than military hardware. By June of 1942, General Electric had completed the initial production run of 5,000 M1 bazookas, each one 54 inches long, weighing 13 pounds, consisting of 2 tubes that could be screwed together for transport, using an electrical ignition system powered by flashlight batteries, and capable of firing the M6 rocket to an effective range of 300 yards, where it could penetrate 3 to 4 inches of homogeneous steel armour. On paper, it was exactly what American infantry needed, a weapon that could be operated by 2 men, required minimal training, and gave foot soldiers the ability to engage German tanks from a safe distance. On paper, the bazooka was revolutionary, but paper had never stopped a panzer, and nobody knew whether this hastily developed, strangely named weapon would actually work in combat until November 8, 1942, when American forces landed on the beaches of North Africa during Operation Torch. What happened next was simultaneously promising and disastrous, revealing both the weapon's enormous potential and the organizational chaos that characterized so much of America's early war effort. Quartermasters unloading cargo in the pre-dawn darkness discovered crates labeled Launcher, Rocket, Anti-Tank 2.36-inch M1, equipment that nobody had ordered, nobody had requested, and, critically, nobody had been trained to use. On the night before the landings, General Eisenhower was shocked to learn from a subordinate that none of his troops had received any instruction in the use of the bazooka, that these weapons were being distributed to soldiers who had never seen them before, had no idea how to load them, aim them, or fire them. Some units tried to figure out the weapons through trial and error during actual combat, which predictably led to failures, misfires, and reports that the new rocket launcher was unreliable at best and useless at worst. Sand interfered with the electrical connections, the visible backblast gave away the shooter's position, and rockets occasionally failed to ignite or wobbled wildly off target. The early combat reports from Tunisia were not encouraging, filled with complaints about a weapon that seemed to promise so much, but delivered only frustration and mechanical failure. But some bazookas worked, and when they worked spectacularly, punching through the frontal armour of Panzer III and Panzer IV tanks with a violence that seemed to defy the weapon's modest size. Soldiers who successfully used the bazooka in combat returned with stories that bordered on the mythological, tales of single men stopping German armour advances, of tank crews abandoning vehicles after a single rocket hit, of the sudden psychological shift that came from having a weapon that actually worked against tanks. The problem was not the weapon's fundamental design, but the complete absence of training and the inevitable teething troubles that accompany any new technology rushed from proving ground to battlefield in less than 6 months. As American forces pushed deeper into Tunisia during the winter of 1942 and spring of 1943, more soldiers learned how to properly employ the bazooka, understanding that the key was patience, concealment, and waiting until tanks came within effective range rather than taking wild shots at maximum distance. Training programs were hastily established, doctrine was written and rewritten based on combat experience, and the weapon itself was improved, with the M1A1 version simplifying the design and increasing reliability. By the time Tunisia fell to Allied forces in May 1943, the bazooka had proven itself as a legitimate anti-tank weapon, but it had also done something potentially more dangerous. It had fallen into German hands. The Germans captured several early production M1 bazookas during the Tunisia campaign, and they did not simply study them as curiosities or file them away as intelligence trophies. They immediately recognized the elegance of the design, the simplicity of the tube launcher, the effectiveness of the shaped charge rocket, and within months they had reverse-engineered the entire concept and begun production of their own version, the Panzerschreck, which translated to tank fear or armour terror. The German weapon was larger, firing an 88mm rocket instead of the American 60mm, which gave it significantly greater armour penetration and made it effective against even the heaviest Allied tanks. The Panzerschreck was first deployed in 1943 and quickly became one of the standard German infantry anti-tank weapons, used alongside the Panzerfaust disposable launcher. The irony was perfect and painful, American ingenuity creating a weapon that would then be copied and improved by the enemy, used against Allied forces for the remainder of the war. This caused some hand-wringing among American ordnance officers, concerns that the bazooka had been a strategic mistake, giving away technological advantages to an opponent who had demonstrated superior engineering capabilities throughout the war. But this concern missed the larger point that Germany could develop superior individual weapons, but lacked America's ability to mass-produce those weapons and distribute them to every infantry unit in the field. The Panzerschreck might have been more powerful than the Bazooka, but Germany could never produce enough of them to equip their forces at the scale America could, and that difference in industrial capacity would prove decisive. The Italian campaign beginning September 1943 demonstrated what the Bazooka could do when properly employed in ideal terrain. Italy was a defender's paradise, mountainous terrain with medieval hilltop towns and stone buildings that had stood for centuries, all of which provided perfect positions for infantry ambush tactics. The Bazooka evolved from purely anti-tank weapon to what military reports called a universal problem solver, used to blast through stone walls, destroy fortified positions, clear buildings, and create passages through rubble when streets were too dangerous to use. During the December 1943 battle for Ortona, Canadian forces developed mouse-holing tactics, using bazookas to blow holes through interior walls so they could move from building to building without exposing themselves to German fire. The mountainous terrain around Monte Cassino, where Allied forces would fight 4 separate battles between January and May 1944, proved especially suited to bazooka employment, with American and British troops using the weapon to engage German positions on reverse slopes and in fortified strongpoints that were nearly impossible to hit with artillery. Fifth Army reports from the Italian campaign documented that every infantry battalion now possessed 24 to 36 bazookas, meaning the weapon had become standard equipment, as common as machine guns or mortars. The proliferation was deliberate, reflecting a tactical philosophy that pushed firepower down to the lowest level, trusting individual squads to make decisions about when and how to engage targets rather than requiring centralized control. The Battle of Monte Cassino itself became a testament to how modern warfare had become a contest of attrition and firepower that consumed men and material with industrial efficiency. The ancient abbey crowning the hilltop was bombed into rubble by over 1,000 tons of explosives in February 1944, destroying a monastery that had stood for nearly 1,500 years, and then German paratroopers occupied the ruins and held them for another 3 months. American forces attempting to cross the Rapido and Garigliano rivers suffered catastrophic casualties. Entire divisions ground down to remnants in fighting that resembled the First World War more than the mobile warfare theorists had predicted. When Monte Cassino finally fell in May 1944, the cost was 55,000 Allied casualties, and what remained of the town was so thoroughly destroyed that it earned the nickname Capital of Ruins. But throughout this brutal campaign, bazookas provided infantry with options they had never possessed before: the ability to engage German armour on unfavourable terrain, to destroy fortified positions without calling for artillery support, to maintain offensive pressure even when tanks could not advance. The weapon's versatility in Italy validated the concept and provided crucial lessons that would be applied during the coming invasion of France. June 6, 1944. Normandy, where American forces landing on Utah and Omaha beaches carried bazookas ashore in waterproof wrappings, weapons that would prove essential during the coming months of fighting through the bocage country of northern France. The Norman hedgerows were agricultural features that had existed for centuries, steep earthen embankments topped with dense hedges that divided the countryside into a maze of small fields, each one a potential fortress. The hedgerows negated many of the Allies' advantages, making air superiority less effective because targets were impossible to spot from above, limiting artillery effectiveness because the dense vegetation absorbed or deflected shells, and creating a defender's paradise where German infantry could establish interlocking fields of fire covering every possible approach. Tanks that attempted to breach the hedgerows either dove nose first into ditches or climbed the embankments and got stuck with their bellies exposed, becoming easy targets for German Panzerfaust and Panzerschreck teams. The fighting devolved into a hedge-by-hedge slog, with American casualties mounting as weeks passed, and advance was measured in fields rather than miles. General Omar Bradley later wrote that the hedgerow fighting was some of the most difficult combat American forces faced in the entire European theatre, a grinding attritional battle that consumed divisions. In this environment, bazookas became indispensable, giving infantry the ability to suppress German positions without waiting for tank or artillery support. First Army records show that in the 6 weeks following D-Day, bazookas accounted for 12% of German armoured vehicle losses in the American sector, a significant percentage considering the weapon's relatively short range and the difficulty of employment in the confined spaces of the bocage. The 29th Infantry Division's after-action reports for June and July 1944 noted that bazooka teams operating in hedgerow country achieved high success rates against enemy armour, developing tactics that involved positioning shooters at the corners of fields where they could engage tanks from the flanks as they attempted to breach the hedgerows. The weapon also proved psychologically valuable, giving infantrymen confidence that they possessed tools capable of stopping German armour, reducing the tendency to panic or retreat when tanks appeared. This psychological dimension was not trivial, because infantry that stands and fights is vastly more effective than infantry that breaks and runs, and the bazooka gave American soldiers a reason to stand. The Germans noticed the proliferation of anti-tank weapons among American infantry and adapted their tactics accordingly, reducing the independence of armour units and requiring closer cooperation with infantry, which in turn slowed German counterattacks and reduced the effectiveness of their armour doctrine. Every building and hedgerow became a potential ambush site, forcing German armour to operate cautiously, which degraded their ability to conduct the kind of rapid breakthrough operations that had characterized their earlier successes. The Normandy breakout in late July 1944, Operation Cobra, finally cracked the German defensive line and enabled General George Patton's armoured columns to race across France toward Paris. The success came at tremendous cost, including the deaths of 25,000 French civilians killed by Allied bombing and the destruction of 3/4 of the region's buildings. Saint-Lô, the key objective of the hedgerow fighting, was so thoroughly demolished that it became known as the capital of ruins, the same nickname earned by Monte Cassino, reflecting the industrial-scale destruction that modern warfare inflicted on anything that stood between armies. But the breakout succeeded, and by September 1944, American forces were approaching the German border, having liberated France in less than 3 months. Throughout this advance, bazookas remained crucial, particularly in urban combat, where the weapon's portability and versatility made it ideal for clearing buildings and engaging fortified positions. By this point in the war, American ordnance was producing 42,000 bazookas per month, and over 500,000 rockets, with production distributed across 237 subcontractors in 34 states, an industrial mobilization that demonstrated America's economic advantages as clearly as any weapon system could. The Germans might produce technically superior weapons, but they could not match this scale of production, and scale mattered more than sophistication when fighting a global war. The final months of the war in Europe saw the bazooka used in every conceivable environment, from the frozen Ardennes forest during the Battle of the Bulge to the urban ruins of German cities during the final Allied advance. The weapon's reliability and effectiveness had improved dramatically from the early failures in Tunisia, with later models like the M9 incorporating lessons learned from 2 years of combat. Training had also improved, with soldiers learning that the key to successful bazooka employment was patience, concealment, and understanding the weapon's limitations, particularly its relatively short effective range and the need to aim at vulnerable points on enemy armour rather than simply shooting at the nearest visible surface. Doctrine emphasized teamwork, with bazooka teams operating in pairs, one soldier loading and one firing, both working together to identify targets and plan firing positions that offered escape routes after revealing their location with the weapon's distinctive backblast. By war's end, virtually every American infantry squad possessed anti-tank capability, a proliferation of firepower to the lowest tactical level that exemplified American military doctrine and reflected a fundamental trust in the citizen soldier to use powerful weapons effectively with relatively minimal training. The strategic impact of the bazooka extended beyond its immediate tactical effects, forcing changes in German tank design and doctrine that rippled throughout their armoured forces. German tanks began incorporating side armour skirts, additional plates hung on the hulls to prematurely detonate shaped charges before they could reach the main armour, modifications that added weight and reduced mobility. German infantry tactics changed to provide closer support for armour, reducing the independence that had characterized earlier panzer operations and slowing the tempo of offensive operations. German war diaries from the later years of the conflict frequently mention the proliferation of American anti-tank weapons among infantry units, noting how this changed battlefield dynamics and forced more cautious approaches to combat. The fact that Germany felt compelled to copy the bazooka concept with the Panzerschreck validated the original design, proving that even German engineers recognized the elegance and effectiveness of the simple, tube-launched shaped charge rocket. The comparison with other contemporary anti-tank weapons revealed the bazooka's advantages. British Piat launchers weighed 32 pounds compared to the bazooka's 15 pounds, were more complex to operate, and had shorter effective range. The German Panzerfaust, while effective, was a single-use disposable weapon with very short range and dangerous backblast, making it inferior to the reusable bazooka in most tactical situations. The true genius of the bazooka was not technological sophistication, but rather the opposite. The weapon succeeded because it was simple, reliable, and mass-producible, using standard industrial processes and materials. The shaped charge warhead used well-understood physics. The rocket motor was straightforward solid propellant. The launcher was nothing more than a steel tube, with an electrical ignition system powered by flashlight batteries, and the entire assembly could be manufactured by companies that had no previous experience with military hardware. This simplicity meant that production could be rapidly scaled and distributed across the American industrial base, ensuring that supply would never limit distribution. By contrast, German anti-tank weapons often reflected excellent engineering, but suffered from production constraints that meant frontline units never received adequate quantities. Germany was a nation that produced exceptional weapons in limited quantities, while America produced good enough weapons in overwhelming quantities, and in a global industrial war, the advantage lay with mass production rather than technical perfection. The bazooka embodied this philosophy perfectly, a weapon that was adequate rather than excellent, but available to every squad in every battalion of every division, creating a cumulative effect that exceeded what any smaller number of superior weapons could achieve. Captain Franklin Johnson, a training officer at Fort Benning, documented in his official report that soldiers could be trained to use the bazooka effectively in one afternoon, a statement that captured the weapon's essential accessibility. No special physical requirements existed, unlike anti-tank rifles that required exceptional strength. No complex calculations or advanced mathematics, just basic instruction in loading, aiming, and firing. This democratization of anti-tank capability meant that any infantry squad could engage armor, fundamentally changing battlefield dynamics in ways that advantaged the side with more numerous infantry forces. The weapon also changed force structure, enabling lighter and more mobile infantry formations that did not require dedicated anti-tank units attached at higher echelons. Battalion and company commanders had organic anti-tank capability within their own units, allowing them to respond to armor threats without requesting support from higher headquarters, which increased tactical flexibility and reduced reaction time. These organizational changes, driven by the bazooka's proliferation, reflected deeper shifts in how modern militaries thought about the distribution of firepower and the autonomy granted to small unit leaders. The bazooka's legacy extended far beyond World War II, establishing the basic template for all subsequent shoulder-fired anti-tank weapons. The M20 Super Bazooka, introduced in 1945, increased the caliber to 3.5 inches and significantly improved armor penetration, though it saw no combat against Germany. This larger version was used during the Korean War, where it proved effective against North Korean T-34 tanks, demonstrating the continued relevance of the basic concept. Modern systems like the AT-4 and NLOW descend directly from bazooka concepts, using more sophisticated guidance and more powerful warheads, but retaining the fundamental principle of a man-portable tube launcher firing a rocket-propelled shaped charge. The word bazooka itself entered common usage, becoming generic slang for shoulder-fired rocket launchers and even appearing in financial and political contexts to describe any overwhelming or unexpected solution to a difficult problem. The engineers who worked on bazooka development during World War II later contributed to post-war aerospace projects, with some helping to build Saturn V rockets for the Apollo program, demonstrating how weapons development drove technological advancement in ways that extended far beyond military applications. General Dwight Eisenhower's assessment of the bazooka as a tool of victory was not hyperbole, but rather an accurate recognition of how this ungainly weapon transformed infantry combat during World War II. The transformation was not merely tactical, but psychological, changing infantry from helpless victims of armoured warfare to effective tank hunters capable of engaging the enemy's most fearsome weapons. This psychological shift had strategic consequences, affecting how armies organised, trained and fought, creating a new paradigm where every infantry unit possessed genuine combined arms capability. The bazooka's success proved that American ingenuity and industrial capacity could triumph over German technical sophistication, that mass production of good enough technology could defeat smaller quantities of superior weapons, that simplicity and reliability mattered more than complexity and performance. From the beaches of Normandy to the mountains of Italy, from the hedgerows of France to the forests of the Ardennes, the bazooka gave American soldiers the tool they needed to stand against German armour and prevail. The cost of production revealed the weapon's essential affordability. Each M1 bazooka cost $36 in 1942, equivalent to approximately $670 today, while each rocket cost $2.90. By war's end, America had produced 476,000 launchers and 9 million rockets, a staggering quantity that ensured every infantry unit had access to anti-tank capability. This economic dimension was as important as any tactical consideration, because a weapon that costs too much cannot be produced in sufficient quantity to matter strategically, but a weapon that costs little and works adequately can be made so numerous that it changes the fundamental character of warfare. The bazooka succeeded not because it was the best anti-tank weapon in absolute terms, but because it was the best combination of effectiveness, simplicity, affordability, and mass producibility, qualities that mattered more than maximum armour penetration or technical sophistication. In this sense, the bazooka represented the American way of war during World War II, leveraging industrial advantages to produce overwhelming quantities of equipment that was good enough to win, compensating for any individual technical inferiorities through sheer scale and availability. The moment that Colonel Leslie Skinner and Edward Oule stood on that range at Aberdeen Proving Ground in May 1942, watching General Barnes fire their improvised prototype with its coat hanger sights, they could not have imagined the full scope of what they had created. They knew they had solved an immediate tactical problem, found a way to give infantry soldiers the ability to engage tanks from safe distances. But the broader implications would only become clear through years of combat and millions of rounds fired in anger. The bazooka's story is not one of brilliant engineering or revolutionary technology, but rather of practical problem-solving, industrial mobilization, and the recognition that soldiers need tools that work rather than tools that impress. The weapon succeeded because it was simple when complexity would have been fatal, because it was cheap when expense would have limited distribution, because it was reliable when sophistication would have introduced failure points, and because it was produced in such overwhelming quantities that every squad could be equipped, regardless of the tactical situation. These qualities, unglamorous and pragmatic, proved more valuable than any amount of technical superiority, and in doing so demonstrated fundamental truths about how industrial nations fight and win modern wars. The story ends where it began, with that morning fog at Aberdeen, with the coat hanger sights and the scrap pile tube, with the moment when an implausible solution to an impossible problem proved itself by simply working. Everything that followed, the hasty production, the confused deployment in North Africa, the gradual refinement through combat experience, the proliferation across every theatre of war, the transformation of infantry tactics, the forcing of German adaptations, all of it traced back to that single demonstration when a general fired a prototype and immediately ordered 5,000 copies. The bazooka became one of the most important weapons of World War II, not because it was exceptional in any single dimension, but because it was adequate in every dimension that mattered and available in quantities that made adequacy overwhelming. It gave American infantrymen the confidence to stand against armor, the capability to destroy what they previously could only flee from, and the psychological transformation from victim to hunter that changed how soldiers approached combat. General Eisenhower called it a tool of victory, but perhaps a better description would be a tool of transformation, a weapon that changed not just tactics, but the fundamental relationship between infantry and armor, between individual soldiers and the machines that had dominated modern battlefields since the First World War. In that transformation, in that shift from helplessness to capability, lies the bazooka's true legacy, and the reason why a crude tube with a rocket and a silly name earned its place among the decisive weapons of the 20th century.